Good morning. Today let us start with the unit 2 regression model. Before discussing the regression model, we start with the regression analysis. What is the meaning of regression analysis? Meaning is regression analysis means the estimation or prediction of the unknown value of one variable from the known value of the other variable. See, in daily life, we come across a number of interrelated events. Examples: the yield of a crop depends on the rainfall. So here rainfall is independent variable and yield is the dependent variable. Now converse is not true. Similarly, the price of a product depends on the production and advertising expenditure. If you change the production and advertising expenditure, the price will also change. So the production and the production and the advertising expenditure is the independent variable and price is the dependent variable. Similarly, the demand for a product depends on its price and the expenditure of a person depends on his income and so on. So these are all the simply examples. If we simply state this, nothing can be done. So prediction is important because prediction or the estimation is one of the major problem in almost all spheres of human activity. The estimation or prediction of the future production, consumption, prices, investments, sales, profits, income, etc. are the very paramount importance to the businessman or the economist. The population estimates and the population productions are indispensable for the efficient planning of an economy. These are the important to government also. Pharmaceutical concerns are interested on studying or estimating the effect of new drugs on the patients. So thus, in such cases, regression analysis is a mathematical measure. It gives the mathematical measure of the average relationship between two or more variables in terms of original units of the data. So, regression analysis is one of the very scientific techniques for making such predictions. So next. So regression analysis. So regression analysis measures the nature and event of relationship between two or more variables, thus enables us to make predictions. Next, the regression is measure of the average relationship between the two or more variables. So average means y in the equation, regression equation y equal to a plus bx, y is dependent on x. So x is independent variable. Such relation, the y gives the average value. The relationship is average value. Utility of the regression. What is the use of that? Degree and nature of relationship, estimation of relationship. It is capable, or the regression, by the help of the regression equation, this can estimate the relationship and can predict also the future values with the help of regression. These are the utility or uses of regression, useful in economic and business research. Now difference between correlation and regression, this already have learnt. However, I just recall the things and I go fast. Degree and nature of relationship. Correlation is a measure of degree of relationship between x and y, but regression studies the nature of relationship between the variables so that one may be able to predict the value of the one variable on the basis of the another. And a cause and effect relationship. Correlation does not always assume cause and effect relationship between any two variables. In the sense, if you give some relationship, any two values, set of values, you can calculate the correlation. The relation is immaterial. It gives one figure. So cause and effect is not is it does not assume at all. So regression clearly expresses the cause and effect relationship between two variables. The dependent variable is the cause and the independent variable is the cause and dependent variable is effect. The continuation, the prediction. Correlation doesn't help in making the predictions. We can't predict at all. So by the two set of values, just we can by the method of the formula of correlation coefficient we can calculate, but we can't extrapolate it. We can't predict anything for the future values. But in the regression, it enables us to prediction using regression line. Symmetry. Correlation coefficients are symmetrical. That is Rxy means correlation between x and y equal to correlation between y and x. But regression is not so. The correlation between x and y, that is bxy, is not equal to correlation between y and x. Origin and scale. So correlation is independent of change of origin but not scale. But regression coefficient is independent of change of origin but not scale. Now types of regression: simple and multiple regression, linear and non-linear regression, partial and total regressions. Now simple linear regression. In the again simple linear regression can be split into three. One is regression lines, regression equations, and regression coefficients. So regression lines. There are two types of regression lines are there. One is regression line on x on y and regression of y on x. See, in the line of regression x on y, x is dependent variable, y is independent variable. So the regression line shows the average relationship between two variables. It is also called as line of best fit. Regression also called as line of best fit. If two variables x and y are given, then there are two regression lines, that is aside x on y and y on x. So y in the linear regression line, y on x, y is dependent variable, x is independent variable. Next, nature of regression lines. If the correlation R or regression coefficient R equal to plus or minus 1, then two regressions are coincident. If R equal to 0, then the two regression lines intersect each other at 90 degrees. So nearer the regression lines are to each other, the greater will be the degree of correlation. So as the B decreases, the regression lines are greater precision. Nearer the regression lines to each other, greater the degree of correlation. Therefore, precision is the more precision. If regression lines rise from left to right, then the correlation is positive. If it is the opposite direction, then it is negative. Now, regression equations. Regression equations are algebraic formulation of the regression lines. There are two regression equations. One is regression equations of y on x, y equal to a plus bx, y minus y bar equal to byx minus x into x minus x bar, y minus y bar equal to r into sigma y upon sigma x into x minus x bar. This is the deviation with between mean. So regression equation of x on y. X on y is x equal to. So x is here the dependent variable. Equal to y is independent variable, a plus by. Similarly, x minus x bar equal to bxy. Bxy is the correlation coefficient between x and y. Bxy into y minus y bar. And x minus x bar equal to r into sigma x upon sigma y into y. These are the different formula. You can use any one of these depending upon the values are given. Now regression coefficients. Regression coefficient measures the average change in the value of one variable for a unit change in the value of the another variable. These represent the slope of regression line. That is known to you already. So there are two regression line coefficients. One is regression coefficient of y on x is equal to byx, that is equal to r into sigma x upon sigma y upon sigma x. Similarly, regression coefficient of x on y is bxy. Not really, x on y is bxy there, y on x is y. So y on x is byx. On the so by seeing this, you can simply you can write yourself the formula. See, r into r is common both sides. Sigma y, byx is, so in the numerator y is there. Sigma y, sigma is the standard deviation of y divided by standard deviation of x. In the coefficient x on y is xy. So r into x is in the numerator. So sigma x is the standard deviation of x divided by standard deviation of y. It is obtained the regression equations like this using normal equations and using the regression coefficients. Regression equations in individual series are using normal equations. This method is also called as least square method. Under this method, regression equations can be calculated by solving the two normal equations. Yeah, what are those? Two normal equations are, so whenever for the regression, we have the regression equation of y on x equal to y equal to a plus bx. Y is dependent variable, x is independent variable. So multiplied by take a sum of that, what happens? Sum of y equal to sum of a, sum of n values, so n values, so na plus b into sum of x, and multiplied by x you get for the equation first. So if you multiply on both the sides by x, you get sum of y becomes sum of xy equal to na becomes a into sum of x plus b into sum of x squared. So another method is byx. Byx equal to n into sum of xy minus sum of x into sum of y divided by n into sum of x squared minus sum of x the whole square. A equal to and a equal to y bar minus bx bar. These are the two methods. Two methods are there. By solving this, you can find out the values of a and b. So first you have to find out the values of b. B is written by like this. B is can be calculated this, and hence you have to put the values of b in this equation, and hence you can measure the value of a. So here a is the y-intercept, indicates the minimum value of y for x equal to 0, and b is the slope for the line, indicates the absolute increase in y for a unit increase in x. Now I can take up an example for that. To fit the straight line y equal to a plus bx. So working procedure, substitute the observed set of n values in this equation, and from the normal equations for each constant, that is sum of y equal to na plus b into sum of x, and sum of xy equal to a into sum of x plus b into sum of x squared. Solve these normal equations as simultaneous equations of a and b. Substitute the values of a and b in y equal to a plus bx, which is the required best fit. So we have already calculated here. See, fit a straight line to the x and y values in the following table. So x values are given 1, 2, 3, 4, 5 up to 7 values. Y values are given here, y 0.5, 2.52, etc. Now take the product of x and y. Say 1 into 0.5 is 0.5, 2 into 2.5 is 5, 3 into 2 is 6, 4 into 4 is 16, etc. other values, and take the square of x, because it is x on y. See, for the straight line fitting the x and y, the values are given below. So x squared values, take the sum of xi squared, sum of yi, and some product of that xi squared, sum of product the x and y. The values are calculated here. Sum of xi is 28, sum of yi is 24, and sum of xi squared equal to 140, and sum of xi yi equal to 119.5, and x bar is the average of x values equal to 28 divided by 7 equal to 4. Y bar is the average of y equal to 24 divided by 7 equal to 3.28. So by applying this formula, you can compute the values of x, a and b. So a equal to small n into sum of product of x and y minus sum of x into sum of y divided by n into sum of xi squared minus sum of xi the whole square. Values are given. See, n is 7, and sum of xi, the product values of x and y is 119.5, and minus sum of xi is 28, and sum of y is 24, divided by n, again n is 7 into 140. Sum of xi squared values are 140, and sum of xi equal to 28, so 28 squared. If you simplify this, you get the values of 0.839. So now a bar, a0 equal to y bar minus a1 x bar. a1 x bar equal to y bar is given here. Y bar is 3.4285, and a1 is already calculated here, 0.83392, 0.83 92857 into x bar is 4, so this is equal to, this gives you, so y equal to a plus bx. In that form it can be written as like this: 0.07142 plus 0.083928759x. This is the procedure of calculating the regression equation. So let us stop here. Let us take up some more examples in the next class. So thank you.